Let's take a more in-depth look at the UDT quarter turn valve. So casting our mind back to the introduction where we looked at what are we working towards, you would have seen on that video that there are a few valves involved in this solution, and most of those are simple quarter turn valves. So this is quite an important piece to our solution, because what this UDT is doing is defining exactly how every single every single quarter turn valve will work. They'll all use the same asset manager, and they'll all use the same UDT to define their data. So we need to think about what exactly is it that a quarter turn valve requires. Now, there are some set structures for this sort of stuff. So most UDTs that are working with an asset will have an IO area, something that defines the stuff coming into the asset and the stuff going out of the asset. We'll have a alarm area, and you'll notice that this has a specific type UDT valve alarms. We have some functionality specific to the quarter turn valve, which is manual requests. And you'll notice that these are structs, and I won't explain exactly what a struct is, what the difference is between a struct and a UDT in any sort of depth here. There is a lesson in the appendix that goes into it in a bit more detail, but essentially a UDT is definable. You can search for it, you can cross-reference them, you can have a look at where they're used. You can't do that with a struct. So they're more on the fly, loosely put together structures. So we have an operation mode, which is how is this asset operating, control status for any asset. We're using UDT asset control status. And then we have a asset status, which is specific to this particular type of asset. So using that as a basis, it should give you a rough idea of the sort of key areas that we're looking at for each type of asset. And if I were to open the IO, you can see that inside this struct, we have two more structs. Not strictly required, and some people complain about having sort of long variable names and things like that, but I personally like to do it because it just makes things very defined and easy to follow. So in here we have our input for open feedback and closed feedback, and it will become apparent where these are used as we go through the course, especially in the input mapping area. We have our output, and notice that our outputs are called like open request and close request, because these also go to a mapping area, our output mapping area. We have a lesson on that later in the course as well. We have alarms, which notice is, like I said earlier, a UDT valve alarms. So every valve has a defined set of alarms. It says UDT valve alarms, so it's not specific to quarter turn valve. You might find that this is also used in modulating valves or valves of other types. So let's just explain. There is a lesson on this as well. So unfortunately, right at the beginning of the course, there's a lot of things that you'll come across that are later in the course where they're sort of defined properly. But we have our indexes, which is the bit that looks up the alarm. So failed to open, failed to close, signal error. We have our current status of that alarm. So that's a numerical value that denotes whether or not the alarm is waiting for accept, whether it's been accepted, whether it's waiting to clear before it can be reset, and things like that. We have our condition. So this is the Boolean value that causes the alarm, because you can end up with the condition cleared, but the alarm's still active because it hasn't been reset on SCADA yet or on the HMI yet. We have our control delays for whether or not all of the alarms are enabled, what's the common time before the common enable becomes enabled, when's the fail to open delay, fail to close delay, signal error delay. So you're starting to see that all of this stuff is encompassed within our UDT for this asset. And because the asset is using UDT valve alarms, if we ever needed to update the valve alarms, this would automatically update because it's looking at this structure as well. And then we have our actual alarm. So this will be something that you'll go and use in the code. Typically, you'd end up using conditions or alarm, depending on whether you need the alarm to be acknowledged by an operator. So that's the sort of alarms. And like I said, we will go through that in more detail, how this all comes together and works with function blocks and things like that as we go through the course. Then we have to think about things like manual requests. In most scenarios and most systems, not everything is just automatic. Like typically things will run in automatic, so you might ask this valve to open if we need to turn on a pump that this valve is protecting and isolating, and we don't want any operator intervention in that. But there are times where we need to manually request the system to open, and I personally like to make a sort of conscious definition between a manual request and a open request. So ultimately our manual request will still drive the output, but for the sake of clarity, simplicity, fault finding, it's a very good idea to say this has come from a manual place. It does make things easier. And again, we'll see that as we look through the actual management of the logic that works with this data. Operation mode, we'll see a lot of any pump, any valve, anything that has an output that moves something should have a operation mode, and this works with the manual requests. So this has our hand push button, off push button, auto push button, the indication, so we can show on our SCADA or HMI whether the asset is in hand off or auto mode, and then a numeric representation, so we don't have to take all of the tags and plug them into stuff on SCADA. It's easier just to have a number that means, 0 is off, 1 is hand, 2 is auto, and also if you were to retain that value, it means that if your PLC goes off and comes back on, you're still in the same mode that you were in before, and you can use the logic to sort of make sure that that happens based on this value. So again, reinforcing the fact that we can nest UDTs and inherit sort of data sets and therefore functionality. If we had a function block that works solely with this UDT asset operation mode UDT, then that means that all of our objects are going to work the same way when we call that function block within them. So control status here, very simply, healthy, unavailable. Every single asset should be reporting whether it is healthy or unavailable. And that will come into interlocking later on, because for our sequences, we want to ensure that every asset is available. And we may want to raise alarms if they're unavailable. So there is a slight difference between healthy and available, which we'll come on to later in the course. Right now it might look like, well, we don't really need unavailable if you're not healthy, but they do work slightly differently, because one of them looks at whether or not we are in auto mode and the other one sort of doesn't. So, but we'll come on to that later. And then asset status. Remember, this is specific to the quarter turn valve. It's got no UDT associated with it. So this is looking at traveling or at position. So when we are not open and not closed, we don't have any input from our limit switches coming into the asset, we would say that we're traveling. If we are in our expected position, we say that we are at position. And it's just making sure that we have all of the data required to actually facilitate these signals, so we can send them back to SCADA, so we can use them in control and interlocking and alarming and things like that. And that's pretty much it for sort of a pre-made setup UDT, such as this one that we've gone through. Some of the things to sort of realize are you can change UDTs as you develop, but we'll come on to it when we do the library management, that you should really try and get your UDTs finalized before you put your system out into production, or you deliver it to a client, or it's in a position where it's actually controlling something, because sort of changing UDTs constantly especially ones that are base objects for other UDTs, can become very messy if you're not really sure what you're doing. And we'll cover that stuff in the library management, and you'll see what I mean. But yeah, it's best to try and sit down, define actually what you need, and build that first. And you can change it, but it's easiest to change in the development phase when you're not actually going to cause any problems. So trying to iron out all of this stuff and sit down and think about the commonalities, that, you know, what's going to use the operation mode, what's going to use control status, and trying to iron that stuff out early is the best way to do it. So let's move on and have a quick look at sort of how do you actually create one yourself. So if I just jump up to the top, inside your PLC, you'll have a folder called PLC data types, and in there will be the action to create a new data type. So if you double click that, it will define the name as user data type 1 or 2 or 3 if you haven't changed other ones, and quite simply change the name to something different. I'll just call this one UDT asset. It's worth noting as well that you can't change the UDT name if you're online. So same as function blocks and things like that. So if you are online to a PLC and you create a new UDT, you're going to have to come offline. Otherwise, it's just called UDT asset, UDT1 or whatever it was called before. So yeah, you can't really create them online. You need to create them offline. So once you're in here, it's exactly the same as a data block. Like, create your variables. So variable 1, select your data type. This one could be a dint, for example. Set whether you want it to be accessible, writable, visible in the HMI and OPC servers and things, whether you want it to be a set point. One of the things that's worth noting is you can't decide whether a UDT is optimized or unoptimized in terms of data. If you don't know what optimized and unoptimized is, then there is a lesson in the appendix that will explain that. Well, it points you off to an article that is written outside of this course, which is just explaining that in more detail. So if you go into properties, you can see that there's very little that you can do in here. You can set a name, a bit of information about it. You get the standard timestamps for when it was modified, changed, created, and library conformance we'll come on to when we have a look at the library management. That basically tells you, is it part of a library and is it healthy in that sense. If we wanted to nest a UDT, then you simply type UDT, because as we said in our lesson 2 for this section, the user-defined types UDTs, there was a note in there that said it's a good idea to prefix all of your UDTs with UDT for exactly this reason, and for cross-referencing and searching and things like that. Not putting UDT on the front becomes really cumbersome when you're trying to remember where things are, what the names of stuff are. I do have projects that have got hundreds of UDTs in, and yeah, putting UDT at the beginning just helps filter out anything else that you get in these sorts of lists. So if I put in here operation mode, you'll see that straight away everything appears in here, and I can't edit anything in here. However, you can set a custom comment, which is useful if you needed to add extra data, for example, for this specific instance of this UDT inside this UDT. So I can't really think of an example off the top of my head, but it'll be something like you'd have a common status setup, but the statuses mean different things for different assets, and therefore you can set the appropriate comment for that asset. And it's definitely worth doing, trying to set base objects, like something that's very common and used in lots of different things, trying to set a generic comment that means a lot to every single place it's used is probably a bad idea. It's better to set custom comments for the area that it's actually used in. So once you've created your UDT, it will sit in this list, In this list, you can create new groups and you can sort of organize stuff, and I encourage you to organize it. Right now, nothing is organized in here, but everything's sort of just chucked in here. But you can appreciate that if we start adding pumps in, if we start adding sequence management in, because UDTs don't just have to be for assets, they can manage how we sort of report statuses for entire systems, how we manage sequence progression. They become very powerful in control applications as well outside of assets. So yeah, getting stuff put into groups and naming those appropriately is it goes a long way to helping keep PLC data types organized. So yeah, one of the things to sort of just think about and take away from this is that it's a good idea to sit down, go through all of the assets that you have, and then sit down and go through each one of those and work out the things that you need from a data point of view. And it's worth noting as well that once you've done this once and you've tested them and you've versioned them and you're happy that it gives you everything that you need, you've tested it with your function blocks, with your HMI, you're set then. And from a testing point of view, you no longer have to do basic functionality testing on every single type of asset. You're just doing integration testing then, making sure that the correct data set has been put to that asset. You know that it's using a UDT, you know that they're all the same, you know it can't be wrong, there's no copy and paste errors, one of them hasn't missed an update and things like that. That can't happen anymore. So there's a lot of merit for fixing a asset to a set UDT.